Good evening, friends. Study with Apala. Chapter 3, Geological Work of Natural Agencies. Resistance to weathering. Mineral constitution of rocks so remarkable variation. In their susceptibilities to weathering, some minerals get decomposed and disintegrated easily, whereas others many remains intact for a considerable length of times with little or no alterations. It has been observed that in igneous minerals, the resistance to weatherings is broadly related to the stage of their formations from a composition's igneous melt. Thus, feldspars, which are alumino silicates and are believed to crystallize from the melts in the initial stage of the process, are easily weathered compared to the minerals quartz SiO2, which is formed towards the last stage. In fact, quartz is one of the most resistant minerals as far as chemical and mechanical weathering are concerned. Within the feldspars, the calcic feldspars are less resistant to weatherings than the sodic and potassium feldspar because the formants crystallize out earlier in a magmatic crystallization process. For most common rock forming minerals, resistance to weatherings increase in the following orders. Dark colored minerals means olivines, augite, hornblende, and biotite. Light colored minerals, calcic feldspar, sodic feldspar, potass feldspar, potass mica, muscovite, quartz. Product of weathering. So weathering is a global process of rock decay and disintegration. So rock exposed anywhere in the walls are subjected to change those very slowly into smaller fragment and new product. The weathering product are commonly classified into two main types: alluvium and diluvium. Alluvium, it is the end product of weatherings that happen to lie over and above the parent rock. It may consist of fragmentary materials resulting from rock disintegrations or fine powdered materials resulting from chemical decomposition, or a matrix of both. The alluviums may forms a thin or thick layers depending on the durations of for which weathering has been operative on the parent rocks. Once the cover is sufficiently thick, the parent rock is always traceables at some depth below. The regolith is another term for alluvium, and diluviums it is that category of end product of weatherings that has been moved to some distance after its formations due to weatherings process. It is invariably associated with weatherings of slopes and forms a heap of various thickness and grade at the base of a slope. Gravity and rain wash are the main agent involved in removal of the weatherings product after their formations. Regolith, the term regolith has been broadly used to express all the weathered materials, alluviums or diluviums that covers the parent rock or is lying close to it. It forms deposit of huge thickness in suitable environment. In most cases, weatherings of rocks becomes slow after the formation of a weathered layer at the tops. This is because the atmospheric agencies, the moisture and gases cannot penetrate effectively down into the rocks through the overlying covers. The exact depth at which the effect of weathering stops varies from place to place depending on the topography, the climate and rocks compositions, but it is generally limited to a few meters only. So the term soils refers to the upper part of regolith that has further undergone biochemical decomposition and modifications, reducing it to a uniformly pulverized state. Soils of almost all type are capable of supporting some vegetations. In this figure, soil profiles is in the residual type of soils: D zone, C zones, B zone, A zone. Depth in meter 963. So make this diagram clear with labeling. Soil profile, it is defined as the record of behavior of the materials with the depth below the surface to which the effect of weathering can be easily established. The emphasis is both on the depth as well as quality of effect. In a typical soil profiles, following four weathering zones are commonly recognized. Zone A, it is made up entirely of a completely weathered soils that may be supporting vegetables cover. These zones may or may not contains enough humus, organic acid produced due to decay of vegetations. Zone B, it is a zones of mixed composition, partially of soils and partially of weathered rock, the latter becoming more dominating with the depth. Zone C, this is practically soil free zones and has enough evidence that rock at this level are already under attack by weatherings, although the effect has yet not becomes pronounced and the rocks are not disintegrated or decayed. Zone D, it is the zones of the so far intact rocks, the parent rocks, the overlying part of which has already been attacked by the weathering process. This zone start from the base of zone C and extend downwards indefinitely. As said above, this about the thickness of a different zone in a soil's profile is quite variables ranging from fractions of a meter to many meters. At places zone A may be completely absent, having been removed after its formation as on slopes. At another place, this zone may extend downwards for quite a considerable depth as in levels land or valley. Mineral and rock formation weathering result in the formation of quite a few minerals and rocks to group deserves special mentions. Clay minerals Montmorillonite, kaolinites, elites are formed as a byproduct of weatherings of pre-existing silicate rocks under humid climatic conditions. Thus, hydrations of volcanic dust is in semi-dry climate result in the formations of Morillonites, kaolinites is formed from the hydrations and carbonations of igneous rocks under humid climate. Ores of minerals, ores of aluminum, the well-known ores of aluminum, so namely is bauxite, Al2O3, and H2O, and laterites are product of advanced stage of weathering of clay rocks. Weatherings leach out silica and many cautions from the clay's rock is in humid climate like those of rainforest, leaving behind rich concentrations of aluminum oxide and hydroxide. Thank you. Like, support, and subscribe this channel. Thank you.